Hello everyone, I hope you all will be in radiant health. So let's start today video with first topic electric potential of chapter electric potential and capacitance. In this we part 1. So this part 1 includes two PDF. One PDF is related to electric potential and its related subtopic, and second PDF it's about electric potential due to system of charges, which include electric potential and potential energy due to 1, 2, 3 and n number of charges, and also due to dipole. So in part 1 we are going to discuss about two PDF in detail with their further subtopics. So let's start our first topic of electric potential. Now before learning electric potential, we have to first learn about electric potential energy in detail, because once we come to know about electric potential energy, only then we can understand the actual define and the physical significance of electric potential. So let's start with the topic electric potential. Now first of all, what is electric potential energy? When you move around in the gravitational field of earth, you may have to make effort. In other words, you have to work by exerting force, and that work is stored as energy of the system. So whatever energy work has to be done against a given field, that is stored as energy. So if work done is against the gravitational field, then energy stored is gravitational potential energy. And if work done is against the electric field, then energy stored is electric potential energy. So whenever we move around the earth, we have to do some work against the gravitational field of earth. So when a body is moving against the electric field due to charges, as we know, all the charges associated with the field. So if this is a field, if a particle has to move from, this is the region of field, particle has to move from point A to B, then it has to do some work against the field, and that work is stored as potential energy. That work is stored as potential energy of the system. So we can say potential energy is amount of work done in moving a charge or a body in a given region of field. Now these central forces are conservative in nature. Gravitational potential energy of electric field, it's also central in nature and it's conservative in nature. Now first of all, what is the meaning of conservative in nature? Conservative forces are those forces which do not depend upon the path followed, but depend upon the initial and the final position of a body. And work done by the conservative forces around a closed path is always zero. Why so? Because the initial and final position is same. Initial and final same, is mean work done needs to be zero. And non-conservative forces, they are contrary, opposite in nature, like they depend upon the path followed. But not depend upon the initial and final position. And for that forces, work done around a closed path is not equals to zero. For which forces? Non-conservative forces. But electric potential energy are here conservative forces. These are the conservative forces. So next is electric potential. Next define is of electric potential. Electric potential is the potential energy per unit charge. So potential energy, it is represented by symbol U. Electric potential energy, it is represented by symbol U, and electric potential is represented by symbol V. Its unit, as it is energy is what? Its amount of work done. So its unit is joule. But potential is what? Its energy per unit charge. So its unit is joule per coulomb. Now potential is energy per unit charge. Which energy? Electric potential energy per unit charge. So we can say energy is equals to charge into potential. The unit of V is also volt. One unit is volt, other unit is joule per coulomb. So we can say what? We can say here its unit is volt and joule per coulomb. So we can say 1 volt is equals to 1 joule per 1 coulomb. And electric potential is a scalar quantity. It's a scalar quantity. It has positive value, negative value or 0, but do not have direction. Doesn't have direction. It doesn't have direction, but it has positive, negative and 0 value. So next is, no need to do this. Now next move to, we can also say energy is what? Work done. So potential is equals to what? Work done by charge also. So it's also defined as amount of work done in bringing a unit positive charge or divided by charge, test charge. Now next are some points related to electric potential. Now electric potential can increase or decrease but depend upon the sign of the charge. Now if electric potential, if it's moving near to positive charge and away from a negative charge, then electric potential increases. But if it's moving away from positive charge and toward the negative charge, then it decreases. As a positive body here and a negative body. Positive bodies are always on high potential and negative bodies are always on low potential. Suppose if a charge is moving from positive to negative, it's moving away from positive and moving toward the negative, so it's decreasing. From high to low, it's decreasing. But if it's moving from negative to positive, it's moving from low to high, then it increases. So next is relation between electric field intensity and potential. As we know, electric field intensity is a vector quantity, but potential is a scalar quantity. Today, so we are going to define a relation between them. There is no need to do the derivation because that's not in the syllabus. You just have to go through the formula that dV is equals to E dot dr, or E dot product stand for cos theta. So E dr cos theta, or we can say E cos theta is equals to minus of dV by dr, where this dV by dr is called potential gradient. Why it's called potential gradient? If a quantity varies with or change with distance, if a quantity change or vary with distance, then quantity is called dash gradient. Now here d by d, this is change with respect to r is what? Distance. So here we can say potential is varying with the distance r, so it's called potential gradient. Similarly, if temperature is varying with the distance r, here temperature is varying with the distance r, so it's called temperature gradient. So a quantity which is varying with the distance or which change with the distance, that quantity is called dash gradient according to that. Now we have some concluded point about this result. First point is, if theta is less than 90 degrees, as we have the relation E cos theta minus of dV by dr. If theta is less than 90 but greater than 0, in that case cos theta value varies from 1 to 0, means value is positive. If this value is positive, then E is going to be negative of d by dr. So potential gradient does what? Their potential gradient become negative and hence decreases when move in direction which is making an angle less than 90 degree. But if theta is 0, means cos 0 is what? 1, then it has maximum negative value. But if cos theta is equals to 180, that means plus 1, at that point it has maximum positive value when theta is equals to 180 degree. So it also decreases but at the fastest rate. If theta is greater than 90, for greater than 90, cos theta has negative value. So E into negative value equals to minus of dV by dr. This negative going to cancel with this negative. So this is going to be then positive. This become positive and increases when it's making an angle greater than 90 degree. Again, this point we have I have discussed with you previously, that if theta is equals to 180, then it says maximum positive value. And if theta is equals to 90 degree, if theta is equals to 90 degree, at that point cos 90 is equals to what? 0. In that case, this is also 0 again. Hence, electric potential do not change when we move in a direction perpendicular to the electric field. This point is quite important. And also the next one, this is very, very important. It's actually, this point help in explaining the concept of equipotential surface. This point is quite important to discuss the point of equipotential, that will cover in part 2 videos. Now, E is equals to 0, then if E is equals to 0, if E is equals to 0, in that case dV by dr is going to be what? 0. If a constant is not changing, if a value is not changing with the it's not changing, then that value is constant. If I take 5, every time this remains to be 5, is it changing? No. Then 5 is what? Constant. This is constant. So if a quantity which do not change either with distance or time, that quantity is a constant quantity. So V is constant over here. So if I have a region, this is the region, here E is equals to 0. So in this region, V is going to be constant. V is going to be constant. Now this constant value of V can be 0 or non-zero. This can be 0 or non-zero. And also, if E is equals to 0, V is constant, means work done in this system is also going to be 0. Work done is also going to be 0 in this system. This point is quite important. So this is the end of PDF 1 of topic electric potential. And please be sure that you make the notes of every PDF and video, so that you can have a great help of that when your classes will be there and you not face any kind of problem. So be particular about making notes along with the videos, so that you cannot face any problem with in any case. So okay.